Okay, so we will talk about George Boole. We'll talk about the relationship between George Boole and Boolean logic. We'll talk about the if else if switch, and I don't think we'll get to this guy, but I'm pretty sure we'll get to the switch statement. So George Boole, he was born in 1815. His father, a shoemaker, and his mother, so his dad's name was John, and when you know it, his mother's name was Mary, right? Like strange common name. So and she was a maid, right? So um, by the age of 2, his father decided to send young George to tradesman school at 2 years old, right? And then we've covered everything in module 2. And okay, where was I? Lost my train of thought here. Yeah, so at 2, he went ahead and they went ahead and sent him to tradesman school, and then at 3 to a commercial private school, I guess, right? And um, his father's friend owned that school, so John seemed to know how to talk to people, right? To the right people. Although he was a shoemaker by trade, he was an avid learner. So Mr. John, he was an avid learner, and that rubbed off on his son. So his son, by the age of 7, so what's this? By 1822, he was very proficient in different languages, and I think by then his father was like, I think my son's a genius, right? So one thing his father always liked to do was he always liked to hang around at the Lincoln Mechanics Institution, right? So this kid was born in Lincoln, sure, England, right? So in Lincolnshire, England, that's where he was born. So his father liked to hang around at the Lincoln Mechanics Institution, right? So, and this was a social club. They promoted reading, they promoted discussions on science, and they had lectures on science. So, Mr. John Boole became the library curator, and I'm assuming that's how he had access uh, to go into this institution, right? And then his son had access to those lectures and discussions also. By age 14, so what's that, 1829? And just in case you were wondering, right? So 5 languages, right? I think it was Greek. I have them here: Greek and Latin, French, um, German, and Italian. So I think by the age of 14, he already knew all those languages. And then he published a poem uh, at the age of 14, the Ode to the Spring. So he wrote it, and his father made sure that it was published for George Boole. Unfortunately, when George Boole was 16, his father lost his shoe shop. So then, what does Mr. George do? He teaches at private schools to support his family. And during this time, he studies advanced mathematics, right? He has access to advanced numbers theory, calculus books, and in 1833, he was offered a job in Liverpool. So he went there to teach, right? So he moved there to teach. And a year later, he's like, well, maybe I'll open my own school. So he opens his own school, and he decides to migrate his family to Liverpool to help him run the school. So his folks and siblings help him run the school. During this time, he kept on studying. Eventually, I guess in the readings, I'm not sure if his school failed or what, but then 4 years later, he took over the Halls Academy in Waddington, right? So, and it was in there, so Halls Academy, and he was offered an opportunity to go to the University of Cambridge, but he declined it because he needed the money to support his family, right? And his family, his siblings, and his parents, right? So, but he kept on studying, right? So he'd been studying for about 8 years, and in 1840, like this kid just doesn't give up, right? So by then he's what, 25. He opens a boarding school in Lincoln, and his family moves there with him, right? So then he opens another school. And while all this is happening, like he's learning, right? He always had that thing for learning. And even though he didn't go to Cambridge, he was publishing math papers uh, in the Cambridge Mathematical Journal, right? So uh, very bright young fellow. And in 1844, he received a very prestigious award, the Society Royal Medal. Society Royal Medal for his papers, right? So notice here, we don't talk about a formal education. So this kid was taught, self-taught. Instead of going to high school, he started working. And instead of going to get a college education, like he just kept on learning uh, while he worked. Uh, to the point that in 1847, running out of space here. In 1847, he published a book, The Mathematical Analysis of Logic. And in 1848, even though he didn't have a college education, uh, he was the first professor of mathematics at Queen's College in Cork, Ireland. So from the readings, he had plenty of letters of recommendation, right? Because by then he was already famous, right? I mean, you write your own math book, and you have a lot of journals posted in the Cambridge Mathematical Journal, right? So a lot of mathematicians at that time gave him letters of recommendations, and he became the first professor of mathematics for the Queen's College. And then a few years later, in 1854, he published his second book, The Laws of Thought. So these two books were the foundation for Boolean algebra, right, and logic. Unfortunately, so Mr. Boole passed in 1864. I think he was 49, right? So he was young, but by then he had accomplished a lot, and he died of pneumonia. And for about 80 years, uh, the educational world, the academic world, they didn't really know what to do with this stuff, right? With the logic and the loss of thought. Not until Claude Shannon, I'm not going to talk about him, right? Claude Shannon made the link between Boolean algebra and information, and then he's like, oh, wait a minute. Like using this, I can represent information, and hence now we have the ones and zeros for computers, but that's not what I want to get into, right? There's a lot of interesting documentaries of Claude Shannon on YouTube, right? So, I mean, there's 5-minute videos that guy was a genius in his own mind, right? So, how about Boolean logic, right? So, Mr. Boole's findings, Boolean logic, were simple. He said, let a symbol represent either true or false. So a symbol can represent either true or false or 0 or 1. Very simple idea. And then he's like, and from here we can say, okay, so we can have an and, so that's an operator, right? That's a logical or a logic operator. And then he said, if A is something and B is something, then some result, right? So he said if A is false and B is false, then the result is false. If A is 1 and B is 0, then the result is false. If A is 0 and B is 1, then the result is false. If both are 1s, then the result is true. And if you look at that, then it seems that we're multiplying, right? 0 times 0, 1 times 0, 0 times 1, 1 times 1. Okay, so that's the AND truth table, and I'll show you how this links to what we're going to be doing with Boolean operators and conditional statements and looping structures. Not only that, he also said, well, there's another logical operator, or. So if A and B, some result, right? So he said if both are 0, then the result is 0. If A is 1 and B is 0, then the result is 1. If A is 0 and B is 1, then the result is 1. If both are 1, then the result is 1. And then there was the not operator. And that one simply meant, so A is something, then the result, right? So this one stated that if A is 0, then if you say not, then it's 1. And if A is 1, you not it, then it's 0, right? Very simple. Very simple. Well, now it is, right? But back then, like this idea was challenged by a lot of mathematicians, right? It's not until Claude Shannon in the 1940s that he made the connection, like, whoa, like this could be the foundation for all our information, that's in cell phones, television, signals. So that's how all that exploded. But how do we connect this to what we are going to do? Okay, so we have the and the or and the not. Okay, there's other symbols, but for this class, we just want to focus on and, or, and not. And let me check those questions. No questions, okay. So how do we connect this to C++? So first of all, in major programming languages, they do support the logical operators and, or, and not. and they support this with symbols. So in C++, it's the double ampersand, and then the double pipe, and then the exclamation point. So with these symbols, you can perform logical operations. And how do we do that? So we do that with Boolean expressions. And what is a Boolean expression? Anything that returns true or false. So is there a data type for this? Yes, it's a bool. So using variables, like if we have a bool like flag equals true, and then we have another variable, maybe just to write less, I'll say A and B, okay? A, B equals false. How else can we produce a Boolean expression? By using the comparison operators, right? Like greater than, less than, equal, greater than equal, less than equal. Sorry. For example, if we say 4 greater than 5, then this will return false. And notice this is a Boolean expression. And if we want to say, okay, something that happened between 1950 and 1970, then we can say, okay, so int year equals 1955. So then we can check, is this year in this range, right? So then we could say year, sorry, it looks like a G, year greater than equal to 1950, sorry for the ampersand, and year less than or equal to 1970, and this is also going to generate one Boolean expression. So and any questions so far, like how we are going to use a logic, right? I don't know if they covered this like in Python, right? But I always feel that it's important at least to understand like where these Boolean expressions come from, right? And they come from this idea or this findings, discoveries that were made in what, the 1840s, right? So and up to now they still hold, like his logic still holds, and we can still use them. So how do we use this for conditional statements? Well, a conditional statement or an if statement, we have to say, let me add a page here, move it down here. So we say if you have to use a parenthesis, okay, some Boolean expression, meaning something that is going to return true or false, and then open close curly braces. So if, for example, let me go back to this example. Oops, not this one. This one. Let me see here. If A equals true, okay, we'll use that one. Like if we have here, if A equals true, then do something, whatever we write here, okay? This curly symbols right here, they are optional, the open close curly brace, but I strongly recommend that you always use them because in the future it may cause confusion, right? You may think that that all the statements after the conditional structure will execute if the expression is true. They will not. If you omit the curly braces, only the first statement will execute, and that may produce invalid results. So my recommendation is always use open close curly brace for the if statement. And the if else, right? So the if else would, we simply add another branch to the if, right? So then we don't write anything here, right? We don't write anything there, but this will execute if false, and this will execute if true. And I know, I'm pretty sure you all know this from Python, right? But I just want to make sure that everyone understands this. And then we can go ahead and write some example code. So any questions so far? So again, make sure that you are paying attention for the foundations of Boolean algebra, right? I'm not going to ask you, when George Boole was born, right? But it'll be like what he discovered and how that helps us with what we do today in programming. Okay, so let me open Visual Studio Code. And we close this one. I'm pretty sure it's this one. Okay. Okay, so we jump onto module 3 and we start writing some code. Let's create this example. So again, make sure that when you write functions, like you need a return type. You have to tell it what the return type is. Here, the name is even, accepts an int, so accepts an int, none. Like you have to tell C++ what data type you will work with. If you don't, your code will not compile. It'll generate syntax errors. Okay, so we jump to the CPP and we include if.header. The names if is just, I just made it up. Like it can be anything, okay? So I'll make sure that students understand that also. Over here, no semicolon after the function name, okay? Instead, you need open close curly brace, and then you can start writing code. So we need to accept that number. Actually, this one should be bool. Sorry, that was me. So we return a boolean. So let me go fix the header. All right, so it says here return bool. So I missed that. So we will send in a number to the function, and then our function will inspect the number and will determine if the number is even or not. How should I do this? Okay, so how do we make a bool? It has to be like some Boolean expression, right? Like, so for example, a comparison, like we compare something with the double equal signs, that will generate true or false, and then we can use that as our return value. So what I'll do is I'll go the long way for this one. I'll create an auto variable, and then I'll say even, and I am just going to assume that it's not even, okay? I'm gonna assume that. Afterward, I'll create the conditional structure and I'll say if the number, and then from most programming languages, if you use this operator, the modulus operator, then this operator this expression right here returns the remainder. So if num is 3, 3 divided by 2 would be remainder 1, so then this expression here returns 1. If we say 4 divided by 2, then that does not have any remainder, so it returns 0, right? So then here we can say, so I can compare this to 0, and if this is true, then I know that the number is even, and then I can set even to true, and I am telling the function I am going to return a bool. Is this a bool? Look, yes. Why? Because we set this to false, and then C++ knows we want to work with bool types. And so before we finish coding, we have to return even. So this code will accept a not number or an even number, and if it's even, it'll return true. If it's false, it'll return false, right? So, and we will test this. Let's go ahead and test it by creating a test case. So we come here, examples, module 3, test case. Returns true or false. True if even, right? Or false if odd. So notice right here, like by writing this, and we are helping ourselves kind of determine how we will test this function. So sometimes it's good to write that. Okay, so before I finish that statement, I have to include the if header. And then I can go here, and then I can say, well, let me test that is even function with the number 4. So that is even. So then what should we put there? Right here. Yes, we should put true. So we come here. And then we can go ahead and execute our test case. Click on the CMake icon. Go find our test. And run in terminal. So it's building. And once we test this, then we'll add another assertion or another require statement, and we will send an odd number. And once we do that, then that's it, right? In this case, this function is easy to test because we can just send an odd and an even, and then that's it. We've tested all the cases, even though there's like millions of numbers. But we know that dividing anything by 2, we will determine if they're odd or even. So our test case is good. And then we'll say, okay, well, let's go ahead and send in like the number 5. And that is not true. So then we have to change this to false. And then we can run our test case again. So we run it. And that's how I recommend you do your homework, right? Like start here and here, write the code, but then immediately go to the test case. Some students, for some reason, they want to go to the main right away and they want to start using their function, but we want to make sure our function works as we want it to work before using it in main, because if this works and it's green and it passes, then I use it in main, then I know my assignment's going to be correct. So then you'll get a good grade. But if you just jump to main and then try to force this to be green, you're just going to add work to yourself, unnecessary work. So 5 even, false, false, and 4 even, true, true. So we can go to main, and then we can use it now. We know it works, so let's go ahead and okay, so create a bool variable named even. Okay, so I can use auto or I can use bool, right? So I used auto in the function. Here I'll use bool. So bool even int variable named value, prompt user for a keyboard number. Okay, meaning like let's say enter a number. Assign the number to the variable. Okay, so we say CIN variable value. Okay, so we have that. Okay, so now call the isEven function with value as its argument and assign its return value to the even variable. Okay, even equals isEven and use value as a function argument. And here display even if number is even. So here we'll simply say if even equals true, cout value is even. If you do this, if even, then it's assuming that you're saying if even equals true. Okay, it's the same thing. And we have a simple program, and we can go ahead and run it. So we come here, src examples, and we run it. And let me scroll down. So enter a number. 10 is even. I want to run it again. I have to hit the up arrow. There's no looping yet. And then I'll use 9. So notice there's nothing, and then we can run it again. Right? So our code works, and that's what we're after, right? So we knew it was going to work because we tested it. So once we use it here, then we should be okay, unless we make like an error sending an error here. But more than likely, you won't make many errors in main. Okay, so any questions? Very simple if statement, right? So. Okay, no questions. So we go ahead and move on, and we'll talk about the if, else, but we will merge it with if, else, if, right? So if I go back here, so we'll work on if, else. I'll show you that example, but then we will add some more code in between to create the if, else, if, right? So pretty sure you all are bright enough to digest that. So let me go ahead and close this one. And we go explore. And we go to if, else, if here. Include, right, include statement, even though it's the header. But we are returning a string, so we know that the string is not part of the core C++ language, so we have to bring it in from the standard C++ library by saying include string. This is the header file, and we'll follow this convention, okay? We won't use the using statement like we do in main. So we'll say start string get generation accepts an integer, say year, and returns a string. Okay, so that's our function prototype or function signature. Copy everything but the semicolon, jump to the if else.cpp, and we come here, open close curly brace, and so If we consume a year, then we'll inspect that year in the conditional branching statement, and we'll return centennial, millennial, generation X, baby boomer, silent generation, or invalid year if we are out of the range of this year. Okay, so we'll start building this out. So we will create a string here, string generation, and before I forget, I will say return generation, not get generation. Okay. Need to do something up here to help myself. So include if else.h. Once I do that, then this errors go away. And now I'm ready to write some code. Okay, we'll start with centennial. So if the year is 1996 to 2014, then return centennial. Okay. If, and for this, we can use the logical operators, right? And we know that this one's produce a Boolean expression, and then we will need to use a logic operator to compare if it's in the range. Okay, so we need to use the AND. Okay, so we go here and we're like, okay, if year greater than equal to 1996 and year less than equal to 2014, then we set generation equal to centennial. Okay, and then I return generation, right? So I go and start writing my test case right now. So I go and say, okay, test case. Test the get generation function. Okay, I think that's okay for now. Okay, up here I need to include if else.h, and then I can say require that if I call get generation with 1997, then that should return, notice it's in double quotes, okay? It has to be in double quotes. Centennial. I know Python, when you use strings, you can use single or double quote. In C++, you have to use double quotes. So don't forget that. It'll cause you to lose a lot of time. Okay, so let me write this. Okay, okay, so let's see what happens here. Run the test case. So while that's compiling, we'll come back here to the code, and our next step will be to create the else branch, but I won't do it yet. I'll let it finish compiling. And we'll say, okay, we'll take care of this one, of this here for now. And then we'll test it, and then we'll go back and add the other generations. This one's millennial generation, baby boomer, and silent generation. I think I can start typing. So here I'll say else. Notice you don't have to put any condition when you use else, right? Because all we're saying is that if this is not true, then execute this piece. So for now, we'll say, okay, so for now, return invalid year. And we're green, so up arrow space dash is enter. So given 1997, then it does return centennial, and that's what we want. We go back to the test case, and we will enter the number for now, 1924, and we know that if we enter that one, then we should have invalid year. And we can go ahead and execute it. And then we can come back to this code, and we have to add the other branchings, right? So this is one conditional branch, and this is another one. So now we'll come back and add 4 more. So we can go ahead and do that. So if year, so notice here, please, on both sides of this logical AND, we have to use the variable name, okay? If you don't, then C++ will generate a syntax error. So please don't forget that. Greater than equal to if else, right? So if else year greater than equal to 1977 and year less than equal to 1995, generation equals millennium. And sorry, else if. And we can go ahead and test this piece, and we go here and we're like, okay, so 1990 millennial running terminal. Line 14 here. This one. The year we are using it to compare a date range, right? And if the date range meets, for example, the centennial date range, then we use the string to save centennial, and then we return generation. 12 here or here? This one? This line 12? We are returning a string, right? So we consume a year, and then we want to return whether that year is in the centennial generation, millennial generation, baby boomer, and we have to do that with a string. So that's why we have a string here. We return a string. Yeah. Okay, so we're good. Up arrow space dash s enter. So far we're good. We come back and look at this code, and we're like, well, let me type in like 1970. Okay, so 1970. So if I type 1970, and then that is generation X, let me double check. Generation X, I go ahead and run it. It should fail because if I go back over here, I've not written any code to handle that period. And that's okay. Like, I just want to show you that if you take this approach, like write the test case, like you know what should return generation X, so we write the test case assertion here, and we let it fail. And after it fails, then we can go back into our code and write just enough code to make this piece pass. And then we run the test case again. And when we do this, now we are letting the test case drive our code development, right? So in this case, like I knew it was going to fail, and it failed. So now I can come back here and I'm like, hey, wait a minute, why did it fail? Oh, okay, so I need to write this branch now, 65 to 76. So I will cheat. So then I change this to 1965 to 1976, and then I say, okay, generation equals generation X. And now my test case will pass. So notice I let it fail, and then I just write enough code to make it pass, and then I run my test case again. So doing it like this, as opposed to writing all the branches first and then going back and creating the test case, and then the test cases are pretty good at pointing out where your errors are. But if you're testing as you go, then you're making sure that as you write new code, your test case are passing. So now you're writing only enough. You're only writing the code that you absolutely need to make your program work, and that's what we want. We don't want to write a lot of lines of code. So now we go to Baby Boomer 46 to 64. 64, 46, open close curly brace, generation equals Baby Boomer. I come back to the test case, and then I can say Baby Boomer. And this one, what year? Like 1950, maybe 1950. Running terminal. And let me make sure it finishes. Once it finishes building, I'll write more code here. Okay, so now I know that the next one is silent generation. So then I'm like, okay, let me write the assertion for that one. And I can use maybe like 1930. I will have to run the test case again, right? So far I'm good, everything's passing. I added this new assertion, let me run it again, and it's gonna fail because I've not written any code yet to handle the silent generation. Once it fails, then I come back here and I'm like, oh, okay, I need to write this branch now. And I'm letting my test case drive my coding, and that's test-driven development. So when they use the test-driven development, they're seeking like as much test coverage as possible in their code, right? Maybe they're writing like a financial application dealing with money, so that they're like I gotta make sure that all my functions work. So then they may opt for this type of development, right? So it failed, and that's okay. We're like, okay, so I come back here, and it's 1925 to 1945. I don't have it here yet, so then I'm like, oh, okay, so let me add that branch. So 1925 to 1945, let me double check that. 25 to 45, and then I have to write some new code here. Generation equals silent generation, semicolon. Notice here, no semicolon, no semicolon, no semicolon, no semicolon, no semicolon, okay? So do not forget that. If you do this then your program may still run, and then it's not generating the correct results, right? So look at this right here. No semicolon over here. Where's the semicolon in the statements here? Is there a semicolon at the end? No. Okay, so please don't forget that. And we go ahead and run this test case again, running terminal. And we're good. Up arrow space dash s enter. Now we are ready to write some code in the main function for this one. And here I'm assuming we just capture a year and we call our function, and this just output what year or what generation that year belongs to, right? So we come here, if else, let me do it over here, main.cpp. Okay, so most of the code's written. Okay, capture year from keyboard, pass the year to the getGeneration function, and display function result. Okay, so we have IOStream included, we have useinstd.cout included, useinstd.in, we have the ifelse.h also in there, so we're good. Now we can say so we can, wait, I wanted to do auto, sorry, auto year, I was still thinking about okay, so this one's considered an integer, and that's good. Now we can say cout, enter a year, cin, capture the year, pass the year to getGeneration function, display the result, right? So usually, like, we want to capture the result in a local variable, because most of the time we want to do something with that variable in the region of code where we call the function. So here we'll say generation equals getGeneration year. So we call the function, we create a variable. What type is it? String. Okay, so we should be okay. And then we can say cout the year I won't get crazy with making sure that well, you'll see what I mean right now. So then we simply say generation. So if we enter an invalid result, it's going to say invalid year. That's okay. And we come to CMake. And we can run it. Okay, down here, enter a year, 1926. The year 1926 generation is silent generation. And then we can run it again. 1900, invalid year. We run it again, like 1980, millennial, and our program works. So again, notice what we are always shooting for. Look at main. Like if we follow the way the book teaches us, like we're writing conditional statements here. For all this code, what we're doing is we're writing all this code in main, and then when you get to functions in the book's like, oh, by the way, there's a better way of doing this. But we're doing it the better way from the beginning, right? So notice how we're always shooting to keep main small. And all the logic that runs our program, main just uses it and leverages it. Like we're not making main large, but more importantly, we're making our code testable. And if we have a testable code, then we can, as our program grows, we can have confidence in adding new features or modifying for bugs without the fear of breaking our code. And that's what we always shoot for. The only reason I have to assign something to year here is because I'm using the keyword auto. If I don't assign something, then that generates an error. See, because auto means, hey, you figure out the data type. C++ is like, I will if you help me out. So we assign 1900. Here it can determine that it's a string because it reads the get generation return data type, which is string. So also notice here that we didn't have to include string here. Up here, mainly because we've already included it in .h. The CPP includes .h, and so do we. So implicitly, we are already including the string. That's why this code breaks. Yeah, I mean, this is okay. Like this is okay. Like I'm assigning a value that I know will generate invalid year, but I know that in the next two lines I'm going to overwrite this value. So I'm good. Like this code should, I mean, it shouldn't cause any confusion. Like if you're working in a development shop, right? Any other questions? This value here, as long as it's an integer, it can be anything. I mean, we can put like something like that. I mean, we're overwriting the value right here with capture input year and save it into year. So whatever value is here will be gone. But usually the best practice is like something that's reasonably close to the values you're working with. 1900. I mean, it's reasonably close. I know it'll return invalid year, which is probably what I want. You know. But I mean, it's going to be overwritten anyway, so it doesn't really matter. It can be anything, yeah, like anything that is an integer. See, integer run. It gets overwritten here, so I mean, I can type like 1930 here, and notice my code still works. So, but usually like something like that. You can, if you want to use explicit data types, you can. I'm just showing you that you can use the keyword auto, kind of like you did with Python, to let C++ figure out the data type you're working with. So there's really no strict rule. And like it all depends on if you go work at a shop that programs in C++, when they give you the coding guidelines, they may say, hey, you have to use auto. And if you have to use auto, well, guess what? You have to use auto. Or some may say don't use auto. So then if they say don't use auto, then that means you have to declare the data types. So, okay, so the only reason a value has to be declared here is because we are using auto. I mean, I can say int year like that, and notice it doesn't generate an error for me. Whatever values in the memory address that we get for year, it don't matter. It's going to be overwritten here, and I'll run this program just to show you that it still gives us the same result. So we go with 1940, right? So silent generation. We run it again just to make sure it wasn't a fluke. 1990, a millennial, right? So our program will still work. Yeah. Okay. And for the assignments, I don't tell you use auto, use int, right? Because I don't know what you're going to encounter out there. So it's good to at least know both, right? Both ways, okay. Where do we go next? We talked about if else, if, and then we'll talk about this guy, the switch statement. So notice here, the switch statement uses the keyword switch, and then keyword case, and the keyword break. So what goes in here? Something that evaluates to an integer, okay? It has to evaluate to a whole number, to an integer. And more than likely, it'll be a variable. How do we read this? So, for example, if this is a variable named num, then is num equal to 1, is num equal to 2, num not equal to 1 or 2, then execute this. So this default will be equivalent to the else, right? So, and we'll go through a full example on this one too. So let's go ahead and do that. Go to the Explorer, come up here, and we go to switch. And here we simply, so returns a string, and I'm pretty sure it's the menu example, I just didn't say it there. So menu, we accept a whole number or an integer data type. And we go to switch.cpp. This has to be double quote, okay? Open close curly brace. I have my switch.h up here already included, so I should be okay. What are we doing here? So usually in DOS programs, you had like a menu, and then you would type like a number to choose an option. So this is kind of like what we're doing here, but we are not performing any action. We are simply returning option 1, 2, 3, or 4 back to the user, depending whether it was 1, 2, 3, or 4. If it's some other number, then we return invalid. Was there a question? No? Okay, so we say, okay, so let's create a string here. What do we name it? String option. Okay, let me return option. And in here, now I can start writing some code. Okay, so I say switch. Oh, I don't even know how I did that. I think I pressed tab and that happened. But it doesn't do it all the time, so I must, oh, whatever. Okay, so num here. And is num 1? If it is, then what I want to do is I simply want to set the option string to double quotes option 1. Okay. And let me go to the test case. So I come back here, and then I can start writing my test case. Okay, so require that first thing up here include switch, otherwise I won't get anywhere. So switch.h, then I come over here and I can say menu with the number 1, according to the rule, should return option 1. And do I have that coded? Yes, so that should pass. Let me go to my test case. Run. So it's building. and building. Hopefully by now, at least you're understanding why we don't write the code in main, like the examples. Right? So we don't write them in main. We just write code in functions and then we use them in main. Right? That's how programmers code. Okay. So option one. So if we use menu with option one, then we expect option one, and yes, option one is. Yeah, we'll get to the break. Okay. So let me. That's a good question. So I'll come here. So then it's here. So what happens? Menu one. Okay, come here. Num is number one. Switch num. So one is one. Case one. Yes. Set option equal to option one and then break. Okay, what happens when this executes? It jumps out of the switch branch or the switch code block, and then this is the next statement that executes. Okay, so yes, it helps. It's just telling it like you're done here, exit out of this function block and come over here. So the next executable statement, which is return option. If we come back and we're like, okay, so let me use it with number 5, and that should return invalid option. I've not written code for it, so it should fail, and then I can go back and just write enough code to make it pass. Run in terminal. So any questions how it executes? So if this was 1, it starts executing, right? This is 1, and then is num case 1 or is num equal to 1? Yes. Execute this statement. Then this break statement on line 19, break means exit out of this function block. So it does, and then it starts executing the next available statement, which is return option. So that's the next step, right? So the question is, if it breaks here, like, why do we need this for? So then that's why I wrote this test case. So it's linking, and so far here, I don't have anything to handle this option, number 5. If we come back here and look at the rules, it's saying that 1, 2, 3, and 4 should return option 1, 2, 3, or 4. Anything else should return invalid option. So default, right? So when I showed you this, right, I said the default is equivalent to else. So we go here and then we say, okay, so it didn't meet any of my options. So then here I will simply say invalid option. And then I'll go ahead and run this again. And then we'll see what happens. Yes, this conditional structures and the data types from last week and the previous week and next week, they're just building blocks to help us create programs, right? So it is very important that we understand what's going on. So notice here now, if I say menu 5 should return invalid option, and then we run the test case and it does. So then default in the switch works like the else in the if else statement, okay? Let's investigate more cases, okay? So we'll go case 2, then option should be option 2, no big deal there. And then we break, and we add another one here. So we say, okay, option 2 will be returned if we use menu 2. And then, let me see, we have enough time. I'll go ahead and do case 3, okay? Case 3 should return option 3, break. And finally, case 4 should return option for break. And we'll go ahead and write the test case assertions here. So we'll say, okay, so let me make sure that the code I wrote is good. So 3, 4, and menu 2 and menu 4, right? So menus 1, 2, 3, and 4 should return option 1, 2, 3, or 4. Anything else should return invalid option. So maybe we should also say, okay, well, anything else, let's try 0, okay? And we come back and let's run the test case. And then once the test case runs, what we'll do is we'll talk more about this guy right here, break, and what happens if we do not add a break after a case. So let's go and see the results. It's linking. We should get the results pretty soon here. We have what, 5 minutes, right? 5 more minutes? Yeah, 5 minutes. Okay, so we're good. So green is good. Up arrow, space, dash, S. Hopefully, when you all are doing your homework and you see green, then you get excited because you know your code is good. So, okay, so what about this, guys? So if we omit break, this statement executes, and then this statement executes, and then break executes, and then it jumps over here. So if I run the test case now, my test case will fail because when I enter 1, it'll return option 2, okay? So let's try that. Run. And notice menu with function argument 1 should return option 1, but it doesn't. It returns option 2. So then our test case fails. Why? Because we removed the break from here. So that tells us, oh, there's probably times when we want something like this to happen, right? Yes. It depends on the situation, right? No, the next week, the one that's due next Friday, you'll need to use this stuff. Okay, so what happens if I omit this break? So then this statement executes and sets option to option 1, and then this statement executes and it sets option to option 2. Finally, this executes, and now option will be set to option 3, and then it'll break. And once it breaks, then it returns option. So our test case should fail with option 3 equal option 1. So let's run it one more time. So notice we see the output, it's 3. Why? Because we removed the break from 1 and from 2, so then it came here, and then finally it's like, oh, you want me to break, and then it jumps out here. So what we'll do is we'll go ahead and fix it, okay? So now our test case will pass. Questions? Usually, I think this was a carryover from legacy C++, and it was used a lot in many driven programs. And I guess because it looked cleaner than the ifs, right? Let me come back over here. So notice how as we start writing more code here, then like it's kind of like, whoa. And for the switch, like you look at it and it's kind of like a little bit easier to read, right? So I think it was a holdover from uh, legacy C++. Also, we don't want to write programs that have like a lot of branching, right? Like maybe 4 would be the max, right? So if we are getting into a situation where we have a lot of branching, then it would be time to inspect our code and break it down into smaller pieces. Uh, no, so here there is a special way to do that. I think you're saying for a range, right? So pretty sure you can do that, but let me look. I want to give the wrong syntax. So it is triple dots, right? So if we want to say like from 1 to 3, so then 1 and then 3 dots, 1 dot 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 3. That would mean like from 1 to 3. That's how we can use the switch with ranges. So the answer is no, you cannot use the logic operators, right? You have to use, the question was, can I use the double ampersand, right? So, and the answer is no. Okay, so let's go into main, and I think we can write the main piece in 1 minute. So let me come here. And what do we do? Okay, so I'll say, so I'll use this, enter, and I'll say num, cout, enter number, cin number, and then I'll say cout menu, as long as I include a switch up here. Num, notice I didn't save it to any variable. Instead, I'll just output the result. And I did that because I wanted to finish fast. So I'll come here and run it. Yeah, so don't leave. There's a quiz. You should see it in the calendar, right? So 4, option 4, right? So it works. I'll upload this code. So let me stop the recording. So